morning. My name is Leslie Salina Villaseñor. I am going to present dimensional morphologic effect on the synthesis of nanohydroxyapatite in the presence of polyvinylpyrrolidone and microwave-assisted hydrothermal. The present work focuses on establishing the synthesis methodology for obtaining hydroxyapatite nanostructures through the hydrothermal method assisted microwave using precursors, the calcium nitrate, ammonium phosphate, evaluation of the concentration of 0.1, 0.2, 0.3, 0.4, and 0.5% of the PVP for dimensional and morphological control. The biomaterials, they are great importance, particularly in the area of medicals for repair or replacement of damaged tissues and organs. These are classified according to the naturals and metals, polymers, ceramics, and composites. Particularly ceramics are used to repair and replace diseased and damaged parts of musculoskeletal system. One example is hydroxyapatite. Is the organic materials that mainly makes up approximately 60% of the bonds. These materials present and crystallite, hexagonal, and monoclinic. The synthetic hydroxyapatite is widely studied for its implementation in the area of medicines, with the has ventured into regenerative science as a bioceramic to control the size and shape of the hydroxyapatite. It's important to employ as surfactants. The surfactants are amphiphilic molecules which have hydrophilic parts and hydrophobic parts. This allows the formation of micella. The surfactants are usually classification for categories according to the form share of the hydrophilic, hydrophobic head, and anionic, cationic, amphoteric, and non-ionic. The PVP is homopolymer. It's a repeat unit contain a highly polar amide group that confers hydrophilic properties, and also not polar metallic group is used non-ionic surfactants. For the synthesis of hydroxyapatite is first the dissolution of precursors, the calcium nitrate and ammonium phosphate. After the dissolution of PVP, subsequently the aggregation of phosphate precursor to a calcium precursor. After the aggregation of PVP, subsequently pH adjusted to 10 pH. After the synthesis at 200 Celsius by 30 minutes. Subsequently, the samples is washing and drying. Subsequently, grinding the samples. Finally, thermal treatments. The results by the scanning electron microscopy, it shows the change of morphology in relation to the increase in the concentration of PVP, achieving the choice of bars, sheets, and agglomerates. After by X-ray diffraction, the information on the face of the hydroxyapatite apparent, also marking an application in the range of the 20 to 14 degrees and 62 to 67 degrees in the 2 theta, where the reflection prohibited for the hexagonal face are observed, which allow to assume the presence of the monoclinic face by FTIR The characteristic vibrational bands of the hydroxyapatite are shown, and the transmission electron microscopy, the formation of nanobars at a concentration of 0.3% ppb is present, and finally present the mechanical of interaction between the hydroxyapatite and PVP occurs through the formation of the hydrogens bricks. And conclusions in the presentation investigation according and reaction parameters suitable for the synthesis of hydroxyapatite were obtained by microwave assisted hydrothermal method, obtained nanoparticles with a main morphologic adverse with average size 24 nanometers wide by 64 nanometers long, and finally based of the results present in this research is should be not that nanorod synthesis at concentration of 0.3% by weight of the surfactant PVP have better characteristics in terms of the controls of the shape and size of particles achieve hydroxyapatite nanorods.